Welcome to Academito. In this video, we will learn about Internet Protocol. It comes in the network layer. It's a logical address at the network layer. Size will be 32 bits. So first I'm going to represent what are the IP addresses are available. I'll write it in binary. So it contains the 4 octets. So the first IP will be this. So in each octet there will be 8 bits. This will be the first IP address. So the last IP address will be when all bit becomes 1. Dot dot dot. So in each, this is the first octet, second octet, third octet, and the fourth octet. So if I write it in decimal, it becomes 0 dot 0 dot 0 dot 0. So 0 dot 0 dot 0 dot 0. I'll write it here. And this will be 255. And this will be 255. And this will be 255. This will be 255. Okay, so the decimal notation will be 255 dot 255 dot 255 dot 255. So so many IPs are available in between that, and which IP to be used for the public domain. So what is private address and what is public address? What are the IPs I can assign to host machine? So you have to learn this. So to learn this, so you have to first look for classes of IP. Okay, what are the classes of IP? Okay, so there are three classes. There are three classes we'll be using in the public domain. Other two classes are reserved for defense research purpose. Okay, so first one is class A. So this is class A, class B, and class C. Okay, so total IP size will be 32 bits. So in this class A, 8 bits are reserved for network, followed by 24 bits are reserved for host. So here N stands for network and host stands for, it is H stands for host. Okay, so 8 bits are reserved for network and other 24 bits are reserved for host in class A. In class B, 16 bit are reserved for network and 16 bit are reserved for host. In class C, so 24 bits are reserved for network and only 8 bits are reserved for host. So what is the meaning of this reserving 8 bits to network and 24 bits? So for example, if you take class A, so here you can connect 2 raised to 8 networks. So per network, how many systems you can connect? That is 2 raised to 24 minus 2 systems you can connect it. So what is this minus 2? So minus 2, one is network address, one is broadcast address. Should not be assigned to any host machine. So that we'll see how to calculate the network address and the broadcast address. So before that, so you should know what are the ranges of class A, class B, class C IP. So that is very important. So what are the ranges? So how to find out that what is class A address, what is class C address, and what is class B address. So for that, you look into coming to class A. So the range of the class A will be 0 to 127. So here class A will be 0 to 127. So I'm talking about the first octet. If the first octet is 0 to 127, that means that you are under the class A, and class B, it goes from class B, it goes from 120. So class A will be 0 to 127. Class B will be 128 to 191. So class C will be 192 to 223. So by looking at these values at the first octet, okay, so you can decide that which class IP address is this. For example, if I write the IP address 10.1.1.1, so this will be class A address. So if I write 168.72.64.14, it's a class B address because we see the first octet falls between 128 to 191. So on the second class C, for example, if I write 192.168.1.1. So these are the examples of the class A, class B, and class C. Then how to find out the network address and the broadcast address? That is very simple. There is network address and this will be the broadcast address. So I'm discussing for the class addresses, class full address. Okay. So not the subnetting. After subnetting, that concept will be different. So now for without subnetting, for regular IPs. Okay. So for this IP 10.1.1.1, just find out how many bits are reserved for host. Here 24 bits are reserved for host in class A. That is 3 octets. That is second octet, third octet, and the fourth octet. So just you make it 0, you will get the network address 0.0. So if you make it 1, all 24 bits, so then the value will be 10.255.255.255. So this 3, I'm talking about these 3 octets. If I make it 0, I'll get the network address. If I make all bit as 1, that means that the value is 255 here. So this, when all bit becomes 1, the value will be 255. So this is the network address and this will be the broadcast address. Okay. And coming to class B IP, for this second IP 168.72.64.14. So here only last 2 octets are reserved for the host. Just make it 0, 72.0.0. So on the broadcast address will be 72.255.255. So on the class C, only last octet is reserved for, so here 168 1.0 and 192 168 1.255. And what about the prefix length? Okay, so prefix length for the class A will be how many bits are reserved for the network. Okay, see here for this class A address, here IP address, this is for class A IP address, the prefix length will be 8/8. And for the class B will be /16, and for class C will be /24. This slash notation, it's also called as CLDR notation. So wherein in Cisco Packet Tracer also it shows like this only, the IP address. If I like this, if I write like this 192.168.1.10, so it will show me as /24. So what is this 24? It's a class C address. 24 bits are reserved for network. So this is called as the prefix length. So this will be the network address and this will be the broadcast address. So this is about the IP address. This is a logical address which comes on the network layer. The size will be 32-bit. It contains the 4 octets, first octet, second octet, third octet and fourth octet. Each octet contains the 4 bits. So classes coming to the public domain, A, B, C is available. D and D is also there. D and D is reserved for defense and research purpose. Class A, the range will be 0 to 127. Class B, 128 to 191. Class C, 192 to 223. And coming to class A, 8 bits are reserved for network, 24 bits are reserved for host. In class B, 16 bits are reserved for network and 16 bits are reserved for host. So what is the meaning of this? You can connect, for example, class A 2 raised to 8 networks and 2 raised to 24 minus 2. Okay. And coming to class B, you can connect 2 raised to 16 networks and 2 raised to 16 minus 2 host. Okay. Class C, so 2 raised to 24 networks and 2 raised to 8 minus 2 host. Okay. So next coming to how to find out the network address and the broadcast address. So and after this, we'll see how to find out the starting address and the last address of a given any given IP. So for example, here I'll take this class C IP 192. So 192.168.1.0. The next IP will be 192.168.1.1. Okay. So what will be the last IP? Last IP will be your broadcast address. So to 192.168.1.255. So and the previous address of the broadcast address will be 192.168.1.254. Okay. So that means that see you can use 254 IPs. So that is nothing but 2 raised to 8 minus 2. So this is the network address and this is the broadcast address and should not be assigned to any host machine. So this is about the IP address and this will be the starting IP. This is the network address and these are the valid IPs where I can assign to any end-to-end device. Valid IPs. So don't assign this network address and the broadcast address. So if you assign broadcast address, the message will go to everyone who is there in the network. So by mistakenly, if you assign this IP address to any host machine, whatever the message comes to that network, it will go to all 254 systems. So that's why you should not assign this broadcast. Okay. So there are 3 types of casting. That is unicast. Unicast means 1-to-1. Okay. So this is unicast. And second one is multicast. Multicast means 1-to-many. And third one is broadcast, 1-to-all. The best example in the WhatsApp, if you are sending a message to your friend, then it becomes a unicast. If you are posting any message in the group 1-to-many, it becomes a multicast. Okay. And if you are sending a message in the WhatsApp to everyone who is there in that network, okay, so that becomes a broadcast. There are 3 types of casting in network: unicast, multicast and the broadcast. So this is all about the IP address. Thank you for watching these videos.